and I want to welcome you to our monthly webinar series and give you a little bit of background on eSig. For those of you not familiar with eSig, we're a membership-based nonprofit organization providing our members with objective information and resources for renewable energy and energy systems integration decisions. We also provide peer-to-peer networking opportunities, information and knowledge sharing, and professional education experiences. Our most recent activity was our fall technical workshop in Denver in October, and our next activity will be the spring technical workshop outside Albuquerque, in fact, next week. This will be followed by an international energy systems integration workshop in London the following week. These workshops deal with the full range of issues associated with integrating wind and solar into electric, gas, and thermal systems. They also deal with the coupling to energy-consuming infrastructures, especially electric transportation, buildings, and industry. Last-minute registration is still available for Albuquerque, and everyone's invited to attend. eSig is a very unique organization, and I don't think you'll find anything quite like it anywhere else in the world. If you're new to eSig, I strongly encourage you to follow up with us if you like what you hear, and I think you will be pleasantly surprised. You can find us at www.esig.energy, as well as on LinkedIn, Facebook, and Twitter. Okay, just a few logistical matters before we get started. First of all, phones will be muted for the duration of the webinar to avoid unnecessary distractions. So please use the question and answer box on the lower right-hand side of your screen to submit questions, and we'll save 10 or 15 minutes at the end for a Q&A. We plan to wrap it up at the top of the hour, and an email with a link will be provided once the presentation and audio file have been posted. We also plan to provide short responses to unanswered questions after the webinar, so don't be afraid to use the Q&A box. Okay, so today's webinar topic is Decentralized, Decarbonized, and Digitized, why blockchain matters in the energy sector. I see a lot of interest in blockchain out there, but I also see a lot of skepticism. At the end of the webinar today, my hope is that everyone will be a little better informed and not feel like they've stepped into an alternate reality when the subject of blockchain comes up, like I did when I first heard about it. The webinar will feature Sam Hartnett, the Research and Marketing Development Manager at Energy Web Foundation. Sam works with EWF's affiliate companies to develop and implement enterprise-grade blockchain solutions. He has a background in energy software development and demand response aggregation. Among other things, Sam managed the demand response operations across the Asia-Pacific region at Enernoc. I feel very fortunate to have Sam here with us today. And on a personal note, as I've gotten in the habit of doing, I took a look on LinkedIn last night, and I found out that Sam and I had only one shared connection. So I took the opportunity to add another one. Sam did a blockchain blog for us last year, and I'm looking forward to what he has to say on the webinar today. The webinar will discuss a number of innovative and dynamic approaches that utilities, grid operators, upstream energy companies, and technology providers are taking to leverage blockchain applications to better integrate distributed energy resources, improve renewable energy tracking, and create new market opportunities. Okay, without any further ado, let's go ahead and get started. Sam, I'm going to turn it over to you.
Great, thank you, Charlie, and hopefully you can hear me all right.
Yep, we can hear you.
Perfect. Well, thank you for the opportunity to present today. And with that, we'll just dive right in. So, let's see. Great. So to start off, I'd like to just kind of level set and talk about why are we talking about blockchain technology in the energy sector? It's most commonly associated with cryptocurrencies and financial transactions. And for folks that are new to blockchain technology, it doesn't necessarily make sense that why we're talking about blockchain in this context. And then I'd like to share a little bit about what we're doing at Energy Web Foundation to bring blockchain applications and blockchain solutions throughout the energy sector at scale and for very large enterprises. Then discuss a little bit about some of the current activity that we're seeing within our network and what to look forward to in the remainder of this year, and then hopefully we'll have a rich Q&A at the end. So first, just a little bit of background on blockchain. And so one of the common misconceptions or stereotypes is that blockchain is really just cryptocurrencies or tokens or coins. And I think an important thing to realize is that those are applications of blockchain technology. And a better way to think about blockchain is in the context of computing technology more broadly. So if we look back kind of at the history of how computers have evolved, in the beginning we had hardware that was relatively specialized, purpose-built for certain applications, very large, complicated machines that only relatively few numbers of people knew how to operate and actually get value out of. And they were limited to fairly basic tasks. But then with the innovation of transistors and then eventually microprocessors, that computing hardware became a little more flexible, it became relatively commoditized, more general purpose. And so a lot of the innovation and the value and the usefulness of computers came from software. And so when that innovation transpired, that opened up the user base for computers to a much wider audience. It allowed you to do more sophisticated tasks with computers and really opened up a whole new transformation in the way that we do business more broadly. And then following the software revolution was really this idea of networks. And so we've seen this today where some of the largest, most valuable companies in the world are really all about networks, connecting many computers together, being able to operate large proprietary networks of data and users and transactions. And that's really given rise to this whole new section of the economy in the tech sector. And so when we think about blockchain, we can think of it as an innovation beyond the proprietary and closed networks that we have today that are owned and operated by single companies, and effectively commoditizing what a network actually does. And so I'll come back to this point, but I find that as a helpful way to think about blockchain and how it fits in the broader context of computing. And so why are we talking about blockchain in energy? There we go. All of our operational and business models are really built upon an energy system that was designed about a century ago. We've got a relatively small number of very large participants at the wholesale level producing power, delivering it one way to largely passive consumers out at the grid edge, and everything from both the physical power flows, but also the flows of information and money are all optimized around this model of producing and delivering energy. And yet now we're starting to live in a world where that whole model is under strain from the rise of new distributed and largely variable and renewable resources that are both physically located at the transmission level, but also increasingly at the distribution level. And so there's an increasing need to coordinate these diverse resources into existing market mechanisms, and the need to have rich and reliable data and then manage the flows of power and data and information across whole new sets of stakeholders is becoming increasingly important. And so we can think about this as the broader idea of reconfiguring a grid architecture. And we have emerging needs that really weren't even relevant a generation ago or even a decade ago. So things like cybersecurity, the ability to coordinate physical assets that are maybe operated by software programs rather than a person behind a desk or physically managing the operations. We have increasing needs to be able to share data between parties in a way that is secure, that meets regulatory standards, and doesn't compromise some of the compacts that we have between consumers and utilities and regulators. And so a lot of these concepts are addressed increasingly through digitalization. And that's a pretty broad term, but within digitalization, blockchain is one of the many specific technologies that we believe can facilitate a rethought grid architecture. And the most compelling attribute of blockchain is that as a decentralized computing network that effectively can commoditize trust between all of the different participants within that network, it is a technology that allows us to guarantee agreement around some set of facts or data and automate execution of certain terms or business logic based on that agreement. If we abstract most of the functions within electricity markets in particular today, but energy markets of all kinds, whether it has to do with registering a new asset into a wholesale market, performing measurement and verification, and eventually financial settlement for participating in that market, new types of transactions like electric vehicles and the need to coordinate data and financial transfer between new parties like mobility service providers, charge network operators, distribution utilities. A lot of what we really need to do is measure some observable data about either a device's attributes, its location, or its physical behavior, reach consensus between different parties about what happened, and then either allocate charges or credits to different parties based upon what happened. And so blockchain is well suited to perform a lot of these functions in an automated way, in a way that disintermediates and potentially lowers costs for all of the parties involved. And I'd like to talk about just a few specific attributes of blockchain that we believe make it really compelling for the energy sector. So one, it's an open source technology that is public and accessible by anyone by default. So that has a few implications. One, it is interoperable by design. So any application that is running on a blockchain environment is inherently compatible with any other application also running on that platform. But also, because it is public and open, it essentially provides a set of rules or instructions for any other proprietary systems that want to interact with blockchain addresses or users or applications. We believe decentralization is also an important component in two ways. So from a literal standpoint, a blockchain is a network of physical computers spread across multiple geographies that are synchronized in maintaining a canonical history of all transactions and data. And that physical decentralization means that there's no single point of failure. Compromising one machine that's running the blockchain doesn't inherently open up the keys to access all of the data or rewrite history. And so that's important from a resiliency and security perspective. And then from more of a political perspective, so on a decentralized platform, there is no central service provider that can change the rules of how an application runs on the system or censor a certain type of application for competitive reasons. And that is, as we've seen, there are certain risks with proprietary platforms that can sometimes limit innovation and competitiveness of smaller third-party developers on certain platforms. On the IoT integration, today conventional approaches typically have some level of trade-off between interoperability and security, whereas on the one hand, if you want interoperability with many different systems. You have to give away some set of access keys to that physical device that allows some third-party application or service to interact with it, but there's very little control over how those keys are managed once they're given away. On the other hand, you can be very secure and very strictly limit who or what has access to a physical device, but that can sometimes reduce some of the value potential of integrating that device with different applications or markets. And so blockchain software clients can enable a very secure and relatively low-cost way of integrating a physical device with a digital ecosystem, and I'll talk a little bit more about that later on. On the immutability front, it's conducive to very granular and high-fidelity traceability of data throughout the system. Once a transaction or a piece of data is logged in the blockchain, there's no party that can retroactively and unilaterally edit or tamper with that data. I think an important thing to point out is that this doesn't mean that if there is some erroneous data that's entered, say a data quality issue, that means that you're stuck and have to live with that error in perpetuity. Rather, you can always append and add things subsequently, but you can never delete what happened. And so this is a compelling attribute for various regulatory use cases, for traceability of physical assets and things like supply chains, digital assets, things like renewable energy certificates, and others. And then lastly, on the trustless consensus, talked about the ability for blockchain to effectively commoditize that agreement and execution of business logic. This has the potential to disintermediate a significant number of business transactions that take place, from wholesale market settlements to utility billing processes. And as we'll discuss in some of the applications I'll talk about later, we were seeing early signs of pretty significant cost savings through a number of processes that have huge potential for the way we think about integrating distributed resources, whereas today, in many of our market processes and regulations are really designed with large-scale assets in mind, and many of the fixed administrative and overhead costs of integrating those assets is not really an issue because of the scale. But when we get down to thinking about integrating very small resources, that admin and overhead burden doesn't necessarily scale down with the size of that asset in existing systems. And we think that blockchain applications have the potential to pretty radically lower the costs of certain elements of DER integration. So what are we doing at EWF to bring this technology to the energy sector? Our mission is to really move this technology from the pilot and proof of concept phase to industrial scale use and applications. And to do that, we believe there's two ingredients necessary. And the first is building a rich and diverse community and to align them around a common technology standard. And that's the second piece there. And so we're actually building a public blockchain infrastructure that has features specifically designed for energy sector applications. On the community side, we have pretty rapidly grown our affiliate network. EWF started as a joint venture between the US nonprofit Rocky Mountain Institute and the German blockchain company Grid Singularity in beginning of 2017. And those logos that you see in the lower right corner there were our initial round of affiliate partners. And you'll notice that those are all large corporate energy participants. But as we've grown, we've really diversified and expanded our network to include utilities, grid operators, startup companies, hardware manufacturers, brokers and regulators in certain instances. And so what we're doing is really crossing the entire spectrum of the energy sector, from upstream extraction to the end delivery to the consumer, to really understand where blockchain makes sense in various levels of the energy system. Next slide. Got a bit of a freeze on the computer here. Apologies for that. Charlie, it looks like my computer is frozen here. Can you still hear me?
Yeah, we can hear you, Sam. Do you want me to share the file?
Let me see if I can escape from presentation mode and if that helps. Well, I appear to be trapped in here because I can't even exit my full screen here.
Yeah, I'm sorry, I was on mute. Sam, I wonder if we can switch it back over so Ryan can run it from his machine, and you can control it, but run it from Ryan's machine.
Sure, I'm happy to do that.
Can we do that, Ryan?
Yep, I'm doing that now.
You always got to have a backup plan.
I think I'm on the screen where you were, Sam.
Yes, and I was hoping to move past this slide here.
Okay.
Let's see.
Want me to give you the ball back to see if that will...
Okay, the backgrounds are different now on the other format, but we can live with that.
Sure. Great. So on the, I've talked a little bit about the community side and the need, blockchain really derives its value from network effects, or in other words, getting a number of different participants aligned around a common standard. And so what's hard to read in the slide is presented here, but this was a survey we took of our different affiliates about which underlying blockchain platform they were using for any pilots or applications that they were experimenting with. And the results were pretty mixed. It was spread around about a half dozen public and private approaches. Some were using custom ones built in-house. Others were using third-party provided services. And so we saw this opportunity to build a common and publicly accessible platform that meets the needs of these energy market participants. And do I have, great. And so our work really focuses on that purple layer there. And our vision is to design this open platform that can connect to the physical world, so different generation assets, flexible loads, control systems, anything that interacts with the physical components of the grid, and then allow them to establish digital identities, create wallets, and engage in transactions through that green application layer. And that green layer is really where our affiliates are most focused. And so our goal is to provide them with that platform that can meet the needs for them to develop applications. And so just to dig in there in a little bit more detail, an analogy we like to use is think about building, in effect, a cloud computing platform or a cloud services platform for applications. Like a traditional cloud system, you need to have a number of functionalities. So both the computation functions to actually execute code. You need data storage functionality. But in the case of blockchain, there's some other characteristics of blockchain that make it a little bit different. And some of the key things I'd point out are naming services. So in a blockchain system, you can think of it as using the internet if we didn't have URLs and we had to remember IP addresses. That is an area that there's a lot of focus on right now, is making blockchain applications and users have commonly readable names, and being able to use blockchain applications no differently than you would using a normal internet browser. The other piece that I think is really important to acknowledge is that because a blockchain is a decentralized system, there's no administrator who can log in and say reset a password. So the need to have solutions to make sure that any users can manage their access keys in a secure way, that they're not lost or compromised, is another big area that's going to be really important to get right. But most of the other boxes in purple there are all things that we've actually started to develop and implement. And as I'll talk about in the next few slides, we're starting to see some exciting development in the application space. So that's really where the focus is this year. Right now, there are probably somewhere between 10 and 15 different applications that are running on the Energy Web test network. And we've also seen a handful of pilots that are now concluded over the last year. And we would categorize pretty much all of the different applications into one of the following categories. The first, environmental attribute tracking. So depending on your geography, these could be renewable energy certificates, guarantees of origin or certificates of origin, or even carbon credits. But in abstract, it's all the same concept of connecting physical devices, either generation assets or consuming loads, to the blockchain, being able to create identities for them, and then measure either production or consumption. In the case of production, creating digital assets that represent certain attributes of generated electricity, and then having the functionality to assign ownership and trade those assets between different parties. So we're seeing a lot of interest in the voluntary REX market in the US, over in Europe, in their certificates of origin market. Some of the pilots I'd point out, the first one we did was with Engie, the big French utility, and Microsoft was the buyer there, essentially automating the full process of procuring voluntary renewable energy credits to meet some of Microsoft's corporate sustainability goals. That pilot involved everything but the financial settlement. And then in Spain, Iberdrola is working with one of our startup affiliates, FlexiDAO, to do something very similar, but with hydropower in their portfolio. On the electric vehicle charging, there are a number of initiatives that we're seeing right now. So PG&E, the California utility, just wrapped up a pilot last year where they were looking at leveraging actually some of the functionality from the environmental attribute tracking systems to meet the low carbon fuel standard regulations in California. And so we're seeing a lot of interest with a variety of companies in using blockchain applications to offer certified green charging products at public charge points, whether either for a consumer-driven approach or through a regulatory-driven approach. But there's a lot more potential that's out there. So Share and Charge is one of our affiliates based over in Germany who's looking to develop an open, decentralized settlement platform for EV charging, with the goal that it would make roaming between networks or roaming between different utility territories much cheaper and more transparent and easier for consumers, so that rather than being limited to one or a few proprietary charge networks, we could have an experience more similar to fueling up at any gas station that you like, showing up, doing your transaction, and being on your way. On the virtual peer-to-peer trading, this is probably one of the areas that's gotten a lot of excitement and coverage to date. We've seen a few limited pilots, and I would emphasize that it really is on the virtual peer-to-peer trading side. So it's effectively using blockchain applications to assign ownership or track transactions from an accounting perspective between different participants, either within a localized market or in a campus setting or in a building, multi-tenant building application. There's a lot of excitement about having full peer-to-peer markets established, but once you start getting into the realm of more dynamic and potentially transactive dispatch of physical assets, some of the implications of just the physical limitations or constraints of localized grids becomes really important. And if you expand that, there's a lot of uncertainty about some of the regulatory implications of individuals or prosumers being able to resell electricity to other peers in the network. But in the fundamental application side, there's some encouraging signs that blockchain can be an important part of facilitating some of those smaller scale granular transactions. And then the last category is around demand response or virtual power plants. So we're seeing a handful of these different experiences. The most notable one I would call out is a pilot that was recently wrapped up by Elia, who's the transmission system operator of Belgium. And they have a mandate from their regulatory authority to open up their ancillary services balancing markets to any kind of resource, whether load, storage, generation, and at any level within the transmission or the distribution grid. And they had historically really been configured from a market processes and operational perspective to only think about large-scale assets on the transmission grid. And so the purpose of this pilot was to automate many steps in the registration process where it's important to link valid contracts between multiple parties, such as the end delivery point, aggregators, suppliers, and the system operator, have any participant in the market posting escrow in order to participate, and then automating different steps of measurement and verification and financial settlement. And what was really exciting about this is that they did some, to be clear, all of this was run kind of in a test environment alongside their production systems, but they had early signs that if they were running this in production, they might see cost savings of 70 or 80% with a lot of their administrative functions. And so that is something that we see as really encouraging towards affirming some of the hypotheses we have about blockchain's capability to lower the cost of integrating smaller scale resources into wholesale markets. So unfortunately, it looks like the slide here is a little bit of formatting off, but I will just speak to this, that now that we are kind of beyond the high level use case stage and we're really focusing on specific applications, that's informing the technology roadmap and very specific functional requirements for this blockchain platform. In terms of scalability, we need to make sure that we have a platform that's capable of processing hundreds, if not thousands, of transactions per second for the applications that we know about today. But if we do believe in a world of much greater DER participation, much more frequent and granular transactions happening, we see a need for potentially tens of thousands or even millions of transactions per second. And that's something that there's a lot of experimentation going on right now. We're happy that we've made some progress there, but definitely a focus for us going forward. The second is on private transactions. I've got a few slides coming up that I'll go into more detail, but the high level is in a public blockchain, by default, any user is able to review the details of every single transaction. It's made that way by design. It helps ensure that that decentralized system stays honest and true. But obviously, in either regulated and or highly competitive energy markets, it's not really practical to have all of the data for every transaction just out into the public. So how can we reconcile that tension? On the IoT integration, I talked a little bit about it before, and I have some details coming up, but doing this at scale and doing it in a way that ensures high integrity of data coming into the system is really important. In a decentralized approach, if you have no central administrator checking and authenticating data as it's coming in, how do we make sure that when we do have devices connecting to the chain that they are authentic? So there's some interesting approaches there. Security tokens is an area where it's more about transitioning existing processes for, say, asset financing or asset ownership into this decentralized approach. And then on token curated registries, can we use some of the native digital assets or digital tokens in a blockchain network to create financial incentives that make it easier for decentralized groups of market participants to align around a common registry or list of assets? And I'll talk a little bit more about that coming up. So where are we today? We have had a test network running since late 2017, and we are preparing in a few months' time to launch the full production version of our blockchain. It is a public open source chain that is derived from the Ethereum technology stack. The most significant difference between the Energy Web chain and Ethereum is that in Ethereum, any entity is able to download the Ethereum software and become a miner, or which is the term for a node in the network that validates transactions and creates blocks. Whereas in the Energy Web chain, we have a mechanism where only known and vetted entities are able to do that transaction validation. And so that intentionally trades some degree of decentralization in favor of increased throughput capacity. So we have roughly 35 times greater transaction throughput than Ethereum, several hundred times lower cost. Folks may have heard about Bitcoin or other blockchains being extremely energy intensive and very costly. That is a intentional byproduct of that the consensus mechanisms that those blockchains use. By having our proof of authority network configured the way it is, we're much cheaper, much more energy efficient, and so that leads to both lower energy consumption and lower costs. We're looking ahead, though. We believe what we're launching is really just version 1, and so as we look to next year, we can talk about some of these maybe during the Q&A, but we believe that this is such a new and nascent space that it's likely that our technology will undergo several pretty significant overhauls over the next 1 to 2 years as the space matures. So just want to dive in a little bit on some of those points from before we get to the Q&A. So on the IoT integration, one of our affiliate companies is called Slockit, and they're based in Germany. And we're really excited about a technology they have called Incubed, which is a blockchain software client that can be embedded on very, very small computational devices. One of the challenges historically of integrating devices into a blockchain environment is that in order to run the blockchain software, you need fairly significant data storage and computation processing power, which just isn't really feasible on things like smart meters or energy management systems. This is a new software system that is able to run on these very light devices and doesn't even necessarily require a consistent internet connection, but can nonetheless guarantee the authenticity of the data transfer coming from the device to the blockchain. And that's one of the pieces that we think is really a critical prerequisite to a lot of the exciting use cases that we see on the horizon. And then just a little bit more on privacy. So we have been experimenting with about 5 different privacy approaches on our test network. And the leading solution that we've implemented so far is a technology called Secret Store. And you can think of it as if 2 parties want to conduct a private transaction, they first set up a separate, they authorize 2 other nodes in the network to be gatekeepers of keys to access the data. And then when they conduct their transaction, it requires those special keys to unencrypt data within the transaction. And the result is you can have a contract that the entire public network can validate that whatever happened inside it is correct from a computation perspective, but they cannot actually see the details of that data. And so, again, we think this is another one of the really fundamental pieces that needs to be solved if we're going to actually see mainstream adoption at any reasonable scale. So those are a few of the highlights, and we covered a lot of ground. So I would be happy to open it up for Q&A for the rest of our time here.
Sam, it looks like people are still thinking about the presentation. So let me ask just a few questions to get started. One is on cybersecurity. You know, cybersecurity is everywhere today. Everywhere you look, people are concerned about hacking and cybersecurity. Could you say a little more about the cybersecurity considerations for blockchain?
Sure. I mean, it's a really broad set of challenges and implications, and I'll maybe touch on a few. So first is maybe the cybersecurity of the blockchain network itself. How can we be sure that the data within the blockchain hasn't been tampered with, or how do you prevent people from hacking in and stealing all the data? So on the tampering, blockchains are so named because transactions, when they occur, are compiled into blocks of data and then added in sequential order to this database in such a way that they are linked to all of the previous blocks that have come before it. And so the result is whenever you add additional blocks to the chain, what you're doing is actually strengthening the integrity and the security of that chain. Because in order for somebody to try to forge a transaction or tamper with data, they don't have to just simply edit one record in a database. They would be forced to go back and essentially rewrite the entire history of the chain. So from that perspective, blockchain is actually, as we've seen with many public networks, Bitcoin, Etherium, those core protocols have never been compromised. Now, that's not to say that there have been 0 incidents. When we have seen stories about either hacks or breaches of a blockchain, what they typically refer to is instances where somebody's keys, which you can think of as a password, to interact with a blockchain application or with a wallet holding crypto tokens. If those keys are compromised in any way, then whoever has them can make transactions or take actions that might be detrimental to the original owner of those keys. So that's one. I brought it up before as something that I think is really important and significant, but there are still risks associated with. In the context of energy specifically, thinking about ways that blockchain can enhance or complement existing cybersecurity measures, there was a really interesting analysis that came out of Pacific Northwest National Labs about the Ukraine cyber attack from a few years back. And one of the core issues in that incident was when the attackers gained access to the operational control systems, they were able to wipe out all of the logs and the audit trails of what they had actually done. And it made it really difficult for the authorities, once the attack was discovered, to actually understand what had happened and how to go about mitigating it. And so in that instance, the PNNL analysis suggested that if some of the audit trails and logging had been done in a blockchain-like infrastructure, it would be impossible to delete those logs, and so it could potentially increase the speed with which cyber responses can be successfully conducted. It's definitely not a silver bullet by any means, like any technology, but there are certain areas where it does have some pretty compelling properties.
Okay. Question here on a DERM says, blockchain seems like it could be a real enabler of distributed energy resource management systems. That's DERMS. Can you comment on how it could be applied in a DERMS environment?
Sure. So where we've seen the most promising progress is complementing DERMS or other dispatch systems to perform many of the administrative tasks, let's say, like registration, contract management, financial settlement, et cetera. It's not, those aren't necessarily the most exciting topics, but they are kind of real barriers. And blockchain's attributes make it pretty well suited to do those things. In contrast, certain DERMS or dispatch systems that are operating on extremely low latency type of programs or markets, those probably cannot be substituted or even complemented necessarily by blockchain. To give a concrete example, on the energy web chain, the fastest that a transaction can be confirmed is about 3 seconds. So if you are operating in an environment where you need sub-second response time or communication between physical assets in order to optimize balancing or grid services in a particular area, blockchain is probably not the right tool for that. But what you can do is then, after the fact, measure what happened and then, perform whatever kind of settlement function you need to do based on what happened. In a way, I think they are complementary and kind of each have their own strengths.
Okay. Question here on the local energy markets. Is EWF doing work on design of local energy markets, for example, peer-to-peer trade of energy services and provision of flexibility services to system operators and wholesale energy markets?
I would say indirectly, yes. So, before we had that slide up there with a number of our affiliates, those are really the companies that are thinking about this most critically. And so we, I would say, act as in an advisory capacity or in a sometimes partnership capacity to help these companies understand how decentralized solutions built on blockchain can help them meet their goals. But we we don't have customers, for example. We don't have a service territory. And so, to the extent that we are working on it, it's typically with our partners. I'll give maybe one example. Stedin is a Dutch distribution system operator who is actively experimenting right now with a localized energy market where I think it's something on the order of about 14 buildings would have the ability to conduct peer-to-peer transactions, but still facilitated through Stedin as kind of the market maker. So that's a project where we helped identify the different technical requirements of what would be necessary in order to actually operate such a market, but that's really their domain, their customers, their expertise. But that's the kind of partnership that we work on a lot.
Yeah. Following up on that question, Sam, you've got a lot of partners developing a lot of applications, and you mentioned the breadth of applications that you see being worked on in the next couple of years. Are there any obvious commercialization plans or routes to commercialization for all of these partners that are developing applications? Do they have plans to offer commercial services based on this at a later date, or do you plan to serve as a clearinghouse? Any ideas about how that might evolve?
Yeah, so there's a few things there. From EWS perspective, everything we are building is open source under a general public license. And so that means any one of our affiliates, or frankly anybody out in the world, can take any of the software that we've developed and use it as long as it stays under that open source license. In instances where certain companies would like to take the open source code base, make some changes to create a proprietary application, and then not release those changes back as open source, the way that these open source licenses work is that is permissible, but for a software license fee. That's kind of one of the main ways that I would say EWF is really commercializing the technology. I mean, it's again, we are not in the business of being a clearinghouse or a market maker per se. We want to really, I think of ourselves more as a technology and advisory service provider for our affiliate companies that are out there.
So you're building the platform, and then the affiliates presumably could commercialize a product using the open source platform once they have their proprietary product developed.
Exactly. Just to go back to the Stedin example, they want to, their motivation is in a year or two from now, some feed-in tariffs for behind-the-meter solar are expiring, and they would like to, rather than be concerned about grid defection, particularly as battery prices come down, they want to incentivize customers in their territory to actually use the grid in order to monetize those assets in new ways through these localized market structures. So from their perspective, that is a new product that they can offer to customers in their territory that happens to leverage this technology stack.
Right. Yeah, a question on, I guess specifically Bitcoin. I'm sure we've all read the horror stories about the transaction verification, energy use, and the projections about how rapidly and how large that could grow if that was the only way that systems evolved. What's your view on energy consumption for the transaction verification, how it changes or how it differs across these different platforms and different applications that are being developed?
Yeah, I would say for any commercial use cases of blockchain, it is very unlikely that proof of work, which is the consensus mechanism that Bitcoin uses, would be selected for a number of reasons. One, it is incredibly resource intensive, so both cache and computation and electricity by design, and that means it's relatively slow, it's expensive to use, So if you're thinking about running, an application or a platform or a market where you're going to have tens of thousands or maybe millions of customers on it, that just wouldn't really make a lot of sense. So there are many, to the tune of dozens of other consensus protocols that have been experimented with, that are in use, and I expect those to gain a lot more traction. Even Etherium, which is perhaps the next most commonly known blockchain after Bitcoin, has historically used proof of work, but there's a lot of activity in the Ethereum community right now to transition to a more resource-efficient system called proof of stake, which uses different financial incentives instead of resource requirements. So it's definitely an issue, but in my view, I think most of the really scalable use cases are going to align around alternatives besides proof of work.
Okay. Another question here. What are the different types of contracts involved in energy sector that can be included as smart contracts in blockchain? Do you have any views on that?
Yeah, so I mean, what's pretty cool is that on contemporary blockchain platforms, there are native programming languages that allow you to express anything that you can think of in code. So from a purely technical perspective, there is really no limitation on what kind of contract you could devise on a blockchain system. The limiting factor, I think, will be the legal recognition or status of those contracts in the eyes of either courts or regulators or whoever the authority is. If you, say, engage in some agreement with a supplier, let's say, in a particular jurisdiction, if that contract is deemed to be legally enforceable through a blockchain mechanism, that has the potential to really change the way that a lot of contract management is done, and I think give rise to a whole new profession of a hybrid lawyer and computer programmer. But where we've seen kind of the initial experiments today have been around things like renewable energy certificates, so establishing effectively buy and sell contracts between generators and consumers of, I agree to buy this many RECs at that price during this time. We've seen in the case of Elia that I described, just a mechanism to validate that there is a valid contractual relationship between different parties within their flexibility market. For example, a delivery point and an aggregator. And then they've actually developed a smart contract that acts as an escrow account. So if you want to bid into the market, you have to post some bond before doing so. And rather than doing that with the clearinghouse, it's now managed automatically by a smart contract. I'm sure there'll be many, many more experiments that come out, but those are some of the early ones we're seeing.
Yeah, some good examples. Thank you. Well, we're about at the top of the hour, so I think we're going to need to wrap it up. As I mentioned earlier, an email will go out once the presentation and audio file have been posted. And we'll also be posting the responses to the unanswered questions once they're ready, assuming we can get Sam to help us out with that. I want to let you know that we really appreciate your engagement. We look forward to seeing you at our next webinar, which is going to be Tuesday, April 23rd at noon. The webinar will feature the topic of electric transport synergy with renewables. And it will be presented by Johan Driesen of KU Leuven in Belgium, from Belgium, so we'll have a little bit of time difference. This is a very timely topic today on the international scene, given the proliferation of distributed PV power plants and the interest in fossil fuel displacement, so I hope you'll all be able to join us for that as well. Further information on all the webinars and meetings can be found on our website at www.esig.energy under events and in our newsletters and the informational emails. So Sam, I want to thank you again for this very timely and informative webinar, and thank you all for your participation. We look forward to seeing many of you next week in Albuquerque or next month with Johan on the electric transportation webinar. And in the meantime, take care, everyone, and thanks again.